Hello everyone. Today we're going to be learning about binary encoders. So encoders are just the opposite of decoders, meaning that they take a decimal input and convert it to its respective binary output. Now the encoders we're going to be working with today are what are called 2 to the n to n encoders, where 2 to the n is your decimal input and n is your binary output. So let's say we have a 3-bit binary output, meaning that we have 2 to the 3, or 8 decimal inputs. We have what is called an 8 to 3 encoder. Alright, so let's start off with a 2 to 1 encoder. On the left-hand side, we have our decimal inputs, D0 representing decimal 0, and D1 representing decimal 1. And on the right-hand side, we have our binary output, which, as you'll notice, we have one output pin, meaning that our binary output is comprised of one bit. So if we input 1, 0, for example, where D0 is 1, that's the same as saying we want to represent decimal 0 in binary with our 1 bit, which is simply 0. Now on the flip side, if we input 0, 1, where D1 is 1, that's the same as saying we want to represent decimal 1 in binary with, again, our 1 bit, which is simply 1. Okay? Let's move on to a 4 to 2 encoder. Again, on the left-hand side, we have our decimal inputs, D0 through D3, or decimal 0 through 3. And on the right-hand side, we have our binary output, which you'll notice now we have 2 output pins, meaning that our binary output is comprised of 2 bits. So if we input 1, 0, 0, 0, this is the same as saying we want to represent decimal 0 in binary with our 2 bits, which is simply 0, 0. Next, if D1 is high and everything else is low, that means we want to output 1 in binary with our 2 bits, which is 0, 1. Moving on, if D2 is high, we want to output 2 in binary with our 2 bits, which is 1, 0. And lastly, if our input is 0, 0, 0, 1, where D3 is high, we want to output 1, 1 is 3 in binary. Okay? Next, let's look at an 8 to 3 encoder, where again, on the left-hand side, we have our 8 decimal inputs, decimal 0 through decimal 7. And on the right, we have our 3-bit binary output. So if D0 is high, again, we want to output 0 in binary with those 3 bits, which is 0, 0, 0. If D1 is high, we want to output decimal 1 in binary, which is 0, 0, 1. If D2 is high, we want to output 2 in binary, which is 0, 1, 0. If D3 is high, we want to output 3 in binary, which is 0, 1, 1. If D4 is high, we want to output 4 in binary, which is 1, 0, 0. If D5 is high, we want to output 5 in binary, which is 1, 0, 1. If D6 is high, we want to output 6 in binary, which is 1, 1, 0. And if D7 is high, we want to output 7 in binary, which is 1, 1, 1. Now, we need to discuss the difference between an encoder with active low and active high inputs. So all the decoders we've looked at thus far are active high, meaning that whatever input pin has a logic 1 on it is the one that we translate or convert into binary. Now, active low is just the opposite. So we look for whatever pin is 0 or low, and we convert that pin to its respective binary output. So active low and active high is just a way of differentiating which pin you're going to convert to binary. So as you can see, this is active high right here. We have D4 as our only high pin, meaning that we're going to output 4 in binary. And here we have active low, where the one pin that's low, we're going to convert into binary. Okay? Now, one final thing we need to discuss is priority encoders. So I'm sure you've been wondering, why can't we have multiple pins as high or active at the same time? So let's say we have a 8 to 3 regular encoder that's active high. If D4, D3, and D1 are all high, how is the encoder going to know which value to convert to binary? There's simply no way for it to. However, if you use a priority encoder, there is a way around that. So a priority encoder essentially takes the highest logic high or active value and outputs that, regardless of what any of the lower pin values are. So for example, if we look at this bottom case right here where D7 is high, the X's represent don't cares, so we quite literally don't care what each of these values are. They could be 0, 1, all zeros, all ones, it doesn't matter. If D7 is high, with a priority encoder, we're outputting 7 or 111. Now, another case, if D7 is 0 and D6 is high, we're going to output 110, irrespective of what D0 through D5 are. Okay, so hopefully you see the pattern. Let's move up to the top here. Where D0 is high, everything else is low. Again, output 0 in binary. If D1 is high, we don't care what D0 is. We're going to output 1 in binary. If D2 is high, we don't care what D0 or D1 are. We're going to output 2 in binary. If D3 is high, we don't care about D0 through D2. We're going to output 3 in binary. If D4 is high, we don't care about D0 through D3. We're going to output 4 in binary. And lastly, if D5 is high, we don't care about D0 through D4. We're going to output 5 in binary. Okay?